This testing question?
Correct, and we call them, it says A-level chapter, Unit 9, Hypothesis Stats. I gave that out a while ago. And it says, I call that Sammy Cambridge. Okay?
Okay.
All right? And I will tell you which questions, of course, anything's fair game on the stats too, and I'll tell you the questions that are fair game. That I'm not going to ask the same questions I asked last time, okay? So whatever was left over, and I'll tell you, why don't I go from Sammy Cambridge, okay? The questions of interest are, ready? And I will go over the T distribution. There is one on there. It is no different than Z. I have to give you the T.
I was going to say, we tried to do one of those yesterday, but we didn't have that table.
I know. You didn't have the table, right? But in the test, okay, it's right here, okay, is I give you for extra credit question, I give you a T table.
Can I ask you a question when you're done doing what you're doing?
I'm not going to be finished until lunch.
Oh,
So is there something I can help you with?
no. Do you think I can come at lunch?
For what? T. And then I think that's it, right? All right, now, I'm going to open up the forum. I know that you like to work on some but you like a little like, hey, I'm lost, what do we do, etc. Tell me which one. You want me to do a T, right?
Yes.
All right,
I did
yes.
number 3 yesterday.
You did number 3, and which 3 was that? The golf one?
Yeah.
Okay, did I start it?
No.
Okay, number 3 for golf,
We just
right?
need
You just need the T?
to do the whole thing.
You want to do the whole thing? Okay.
Yeah, let's just do that.
Okay, this is the first, the handicap committee.
I have no idea.
Yeah.
Okay, that's a Z. Did I say T or Z?
You said T.
Oh, crap.
Do this whole thing.
That's okay.
Wait.
I'll show you how to do this anyway, okay? You'll be all right. I think the next one. Okay, so this one's the handicap golf, guys, right?
That's a Z?
Okay. The handicap golf, I'm seeing if I have the right one. I do. Okay,
Okay.
here we go. This is number 3 off of Stats 2. All right? So why don't we just start listing some important information to save some time, okay? And this one talks about, the club members was 85.9, right? So, all right, that's an 85.9. Yeah, that's good. Next one says, looks like that 85.9 is what? The claim, right?
Management.
Management's mu.
The government.
Right? Is that one, right? Okay, what else does it give it? It gives 100 golfers. What's that stand for? And's 100. Good job. Now it gives us this weird stuff. It says E of X is 83.50.
The sum of X.
The sum of X, right? You know what you're going to do to that guy, right? Yeah. Divide by N, rocket science.
And now we've got
you
X bar.
this guy. This guy's a little different.
That's part of the standard deviation.
That started standard deviation, 6399. So this goes with the average, X bar, and then this.
It's not 69.
It's 15,321.
Oh, okay. I'm copying off time. Okay, 15321. Thank you. It's hard for me to see, okay, because I'm old. All right, and then it wants to know about the claim if it's justified or not, right? And it says 8 marks. Wow, that's a lot of points, right?
Yeah.
So the first thing is you set it up. You set up the null and the alternative. Now sometimes you might see a 1 there. If you put a 1 there, that's okay too. What's the null? U is?
Equal to 85.9.
Yeah, they're claiming that everybody's going to get 85.9, right?
Yes.
That's what they're doing. Now, what is the
Ha.
U is not equal.
not equal, right? And what told you that's not equal?
Because they said that they're changed.
It's changed or differs or whatever. That's the type of language, okay? Boom, there's one. Not bad. Okay. Now we got to do what? Well, we got to do the T-Statistic, right?
Yep.
And now in order to do that, it said alpha was what? Alpha was 0.5? 0.05?
Yeah.
So that's a 1.96.
Because it's alpha over 2, which is 0.025, which is
0.25, and then
1.9.
he's right. Again, he's 1,000% right. Yeah, he's already doing it. So then that's the first one. Then the second one's the T-Statistic. We could do the Z, right? So why don't we see what we're missing, okay? Well, we don't have X bar. X bar is going to be this thing right here over N. And so that's going to be 8350 over 100. And 83.5. Holla. Okay. So that's, sorry, so that's 83.5.
Minus 85.9.
Minus 85.9, too easy. I'm just make sure I'm not getting confused. 85.9. Now, do we know standard deviation? Not straight off the bat.
We can find it.
But we can find it, yeah. We got this part.
Yeah.
What do we do with it? We just ask Murmer.
Divide by
The square root of the sum of x minus x bar squared over n.
Yeah, he's doing all that stuff, right? So you start off with s squared, right?
Yeah.
Now, since it gives this to you, okay, you don't have to do a lot of work. It's 1 over n minus 1, okay, that's the first part. Okay, now what's the next part? You just put that number right in there. It did all the stuff for you. Okay, yep. And that's going to be, remember this is going to be squared, right, or whatever. I'll square this, and that's going to be 15,321. Okay, and so this one here is 100. So it's 1 over 99 times 15,321. Everybody okay?
Mr. Murmer.
That's me.
For some reason I did square root of the sum of x minus x bar squared over n. Like I didn't do the 1 over n minus 1.
You would probably still get credit for it if you did just the end.
We use a slightly different formula that's still on the sheet. that we
It's
can-
still
Yeah.
okay. You still be fine. Now, when you get this one here, right, it's still going to be a big number. It's like 154 and change, right, without taking the square root. So this is going to be bracket, right, 154. This is what they got, 154. I'm trying to read it real fast. I get lost because I go up and down here. 154.76. Now, this number here is what? It's not standard deviation, it's the variance. So what do I have to do? Square root 154.76, and that's roughly 12.44. Good?
And I got 12.378.
I got 37. I might be.
No, because we did the different
You
formula.
might, and you're still okay. They still give credit for it.
You still get the right answer.
You still get the right answer. You know, you're all right. So I'm going to use 12.44, and you can use the 378, okay? Over the square root of what? 100?
Yes.
Now, if you wanted to, Billy would say, hey, just put 154 or whatever it is. It would be what? Sigma squared, s squared over 10 or something, right? Yeah, you do that one as well. Okay, now this roughly comes out to what? It's going to be negative, right?
Yeah.
And they got negative 1.929.
I got negative 1.939.
See, he's more exact. Okay, and that's fine. I'm not going to take off for that at all. Because they do give you leeway because how you calculate it. And they'll be that way even if they're mixed. Okay, gradient. All right? Even if I was there, like, you know. Because it's not an exact science, even though we think it is. All right? All right, now what?
Yeah, it's never.
You got to set up the chart, the
Yeah.
distribution.
Here, this. I hope you do this picture because it helps me 100% what's going on. You know that's minus 1.96, yeah. This is 1.96, yeah. This is where the hoe lives. I mean the no lives. Okay. Okay. Region, critical value, right? So if he's inside here, whomever, it's like little piggies. If they're in the house, they're okay. Until the wolf. If they're out here, then the big bad wolf gets them. Okay. Now this is if they're in the brick house.
Where does the T come in?
I haven't talked about T. This is a Z. This is a Z. I will do a T in a moment. I did. I didn't mean to. The other golf one is a T. Okay.
So
This one is the golf handicap cap, right?
yeah.
This one's okay. This one's I think I said that. I probably didn't mean to.
Okay, there's 2 3 1s, and there,
It goes number 6 and number 3.
and then 5.
The one above it's a T. The one below it that says number 3 for handicap of golf is a T. Guys, you do the same process. You do. I will do a T one in a
What
moment
makes it a T, though?
You have to calculate
because
sigma.
the sigma's unknown.
So why can't
But the
That's the only
sigma was
difference.
unknown.
It's partially unknown. I got it. What they do is they list a whole bunch of data. I got it.
Yeah.
They list a whole bunch of data, right? You know, like number 6 for the sherry or whatever that number is.
Yeah.
They give you a whole bunch of data and they tell you like N's 15, Mr. Shrivel, and figure out this. And they don't say this. And they said start doing the test. So if you have just a whole bunch of data and whatever it is, and then sigma is truly, it's called truly unknown. Then you do that formula and then you use a T. And I'm going to give you the T critical so you know it's a T distribution.
The hoe lives in the mountain.
I said the whole lives on the hill.
1.92 is right here, right?
Yes.
Negative 1.92?
Yes.
Under the hill.
It's the Santa Claus mountain.
It's the Santa Claus.
Ho,
Yes,
ho, ho.
it is. It is. It's see, it never stops. It's the same way in college too. Okay. So what does that mean? Do we failure to rejection? You can write FTR if you want, or you can write reject. reject the null, and so on.
Alright,
Okay?
yes.
Now wrap it up. That's 3.
Failure to reject.
And then wrap it up for me.
There is
There is.
stat sig that the
There
mean.
is.
Not.
Say it that way. There's insufficient, or there is not stat sig.
That the mean golf scores have changed,
That's right. Perfect. I love what he said.
meaning they haven't changed.
They haven't changed for squat. So whatever management says, that's what it is.
Right.
Even if you're working with a whatever, okay?
Yeah.
You go with the mean. You go with what she says to make General Mills products. Okay? I work for her. I have to go with what she says because that's what happened. All right? I'll do a T1 in a moment, okay? It's the same process. It's exactly the same. The only difference is you got to calculate it.
do with it? Why can't you just use the z-score is the thing? Like,
Because they use a different table, and I can go into it even longer, but you don't want me to, but I'll just say it hopefully in 3 sentences. Because the T mimics what the Z does. It's not a true Gaussian.
but once, okay, so like. Once
So they
you
use a different calculation.
Because we use the same formula, so don't we have the z-score? So like, why can't we?
I'd have to give you the T table. You can't use T's for Z's.
Which number do you turn into the T? When you find the Z formula or the alpha?
Say that again. Hopefully I can get this.
Where do
Say
you
it.
get the T from? There's a chart with a bunch of T's in it, and what do you?
Well, the chart will say T distribution. And how do you know?
Is it the alpha that you're using the T for?
Well, the alpha is always the same. It could be 0.05, 0.1, whatever. I mean, that's arbitrary, right?
Yeah.
What makes you use the t-test, right?
Yes.
Okay, the one that makes you use the t-test is like the first one that was on here. That was a disaster. The bottles of sherry.
Yeah.
Look at, they gave you what? They gave you all this stuff, right? And then the first thing they give you all those, you have to calculate sigma. Sigma's unknown. You got to use that formula. Now you're lucky, okay? Now you're gonna not like me, and then you're gonna like me later on. You're not gonna like me now because I know the test, and I'm doing one t-test, right? But I'm gonna give you the formula for the t as well as standard deviation, and then I'll give you z on the side, and then sample proportion, right? Those are all the same things. It uses the z, pq, p minus q. Remember?
Yeah.
Get that. But the biggest thing is later on in college, what's gonna happen is they're just gonna put that on there, and then they're gonna give you like 4 different tables, and they're gonna go ahead. And you're going to be like, oh man, I remember doing this. Okay, hopefully, right? Yeah. But I will tell you what test to use. The only one there's only one problem on there that's a T, and I tell you T or critical is this. Right away, you know you got the t-test,
Okay.
and you're going to calculate T. Remember, instead of a Z, there is a T. Okay, and then you get this guy, then you compare it, and you do the same thing.
Okay, so
No different.
The only difference is that
Sigma's unknown.
not with the
Completely truly
The
unknown.
difference is the critical values, instead of being what they are, like if it was an alpha of 5%, right?
0.05, yeah.
Yeah. Here we use the critical values of 1.96. And
Yeah, these will
that's
change.
what would be different.
These would change. This one might be a minus 2.325. This might be some other value. The process is exactly the same.
Okay, so T comes in. And
Alpha is always the same. T changes with respect comparatively to Z,
what type of?
based upon the test.
Gotcha.
So T is less accurate than the.
Yes, that's correct. Unless you do like about infinite amount of
So
trials,
why do we use T?
because not everything works as a Gaussian.
Since they give you the data set, how is sigma truly not unknown? Can't you just do the math and figure it out?
Because you don't know whether or not you're using a T or a Z. Because if sigma's unknown, then you don't know if it's normally distributed.
Oh, okay, that makes sense.
There we go.
A lot of sense.
You not normalize it. There we go. It's finally figured it out. Yes, Nick.
So then, how would there be a situation where it wouldn't be a normal distribution, like because he couldn't find sigma?
He doesn't know, or Gossett didn't know, and he was doing all that. Did I talk about Guinness?
Yeah.
Gossett didn't know, and then he found out that it mimics the Z's in the Gaussian, and that's what he did. Then later on, he published it and said, "Well, I don't want people to know what I'm doing, so I publish it under, student. Let's say Sophia did it, and she just uses her first initial S, and that's what he did somewhat as well. Okay, this isn't bad, right? This is a T. I will direct you T. If I don't say anything, you know it's a Z. If I tell you the T critical, you know what you got to do. All right.
Yeah.
Bitter. Yes, I'll do a T. Okay. Yes, I will. Do a T. Is this okay for the number 3?
Yeah.
This isn't bad. You divide this. You put it in this archaic formula and so on.
Yeah.
Pretty good. That was the hardest. Exactly. You might see something like this in the future.
Let's do 6.
6, which one?
Right
Another
above-
golf one, or?
Right above the golf.
What's the
All
other?
right, hold on.
Lifetime camera.
The Everwhite camera battery?
Yes.
The cameras? Okay, that is a classic T, okay?
When you're
And I'm trying to, and you are fortunate, let's put it that way, because, why is that, Murmer? Because they're not gonna make you do T's. But when you get out of like this bubble of a planet that you live in, planet Rockledge, they're gonna make you do stuff of that regard. But I want you to be prepared either way, so that's why I didn't like truly emphasize T's. But Cambridge maybe moons ago did, and I didn't know. So then I'm like, well, I can't throw it away because I'm wasting their time. All right, so this is the lifetime of batteries and everything else, right? And I told you that it's T. Okay, so we got what, 85, 92, 100, 95, and 99. Am I doing the right one?
Yeah.
Yeah.
Yeah, okay. So far, so good? Okay, it says alpha's what? 0.05. All right, okay. Then it says this, sigma is 80, and this guy is X
Well,
minus.
there's a first part to it too.
I know, I'm just writing everything. I'm getting all the data. 99, okay? 5%, 100 batteries, everything else. Okay,
That's
A.
the C part.
Yeah, I'll get to it. Yeah. So, the first part says what? Do the test, right?
Yes.
All right, so let's see here. Investigate suspicion, random 5 variables. Which test do you want to do?
T.
Okay, we know it's a T test.
Because we don't
Left,
have-
left, right, two-tail.
Two-tail.
We can do 2. It won't matter. Okay? They did 1, but you can get away with 2. All right, so we're going to do two-tail. I would give it,
Does it give us the mu?
we got it right. And what the mu was, what did they say? I got it. 100.
It
So
says
use
do not
100.
last as long, so it'd be less than.
Yeah, see, say it again.
It says do not last as long, batteries don't last.
Does not last as long. One tail. Let's stay consistent. There, you read it, okay? You get away with doing 2, right? But I want you to be more consistent. Okay, so far? Now, I'm going to write something on here. DF. What's DF stand for?
Degrees of freedom.
Degrees of freedom, which is N minus 1. America. So you're going to take this random sample here. There's how many pieces of data? 5. Minus 1, and that's 4. So far, so good?
Yes.
So, I know, I'm expanding your knowledge base. If you had a T table, you would look at alpha and degrees of freedom. What's that mean, Murmer? Well, alpha's what? 0.05.
Yep.
And our degrees of freedom is 4. So on that table, wherever it is, it's just fantasy table, you would go, alpha's up on the top, degrees of freedom are here. And you'd look it up just like a Z.
But we don't have that.
But you don't have that, I'm going to give it to you. Okay?
All right.
All right?
We got to do 1 over n minus 1 times some of
Yeah,
that.
yeah. So they got here, so pretend you had the table, you looked it up, and you're like, Murmer says it's minus 2.132. Okay?
What was it?
Negative 2.132. All right? I have to give it to you on the test. I have to. All right? Here we go. The ho and the ha.
Ho, ho, ho.
Ho, ho, ho. Mu, mu. Mu is what? Equal to
100.
100. And we said it's a one tail, and it looks like less than 100. Okay? Now, later on in a real stats class, you will say this. Because it's a one tail. Does that make sense? And I'll do that in a second. Don't go crazy on me, but
No, it's like the same thing.
exactly. It's everything that's more than,
It's
right?
just a different way to write it.
Exactly. Okay? Now, the T-statistic. We're going to say instead of Z, we do T, because it's the T table. You do the same thing. You say X bar minus mu. Okay? And they like mu sub naught, which it doesn't matter. Okay, so far? And then we're going to say S over the square root of N.
So we have to find X bar
And sigma.
And sigma.
and sigma.
All right, well, X bar is a rocket science one, right?
So hard.
It's easy.
That's 100. Square root of, what's this one? 5, right? So if I'm gonna, and you're going to tell me what X bar is. I can't put there. That's
So
letters with
calculate
numbers.
it. I'm too lazy.
I'm doing it.
Did you get 94 too?
Yes.
Okay, now S. Okay? Now pretend we don't know this. We just know this. All right? You can get it if you want. from that one there, because you can, leech onto that one, so to speak. But pretend you didn't have this, and then you had to turn the page like, oh crap, right? That was another round. So how do we get it from here? You can use the formulas, right? Remember? Which one do you want to use? I don't care.
For the sigma?
Standard deviation, right?
So we do 1 over n minus 1 times, isn't it?
Yeah, you can do that one, or you can do the other one, right? I don't care which
And
one.
you just square the differences between the mean and the data, add them up, divided by n minus 1.
And then square root.
Yeah.
Yeah. He's doing this one. He's doing the classic one that I know forever.
I think that's the easier version.
Which one?
He's doing this one.
What's it on?
Okay? Now, if you don't know that one, and you're given this stuff, you got to use that other guy, right? Or whatever. Okay? So we can do this one if you want, right? But you got to know what X bar is. You already told me it's 94.2. And you subtract each individual data set from this and add them up, because that's what the sig means. Square them, add them up, and then divide by 4, right? And so to save some time, just for fun, they got, I believe, hopefully I'm reading it right, so I don't get confused. I get confused so quickly. Here it is. 6.058. Okay? I can show you how to do this. You want me to show you how to get it, or you okay? I showed you that 2 years ago.
I remember.
Yeah.
I know you remember.
You
Remember I made you
sure?
the table? Yes, ma'am. I was a SOB on it.
So,
You're welcome. Yes, sir.
well, how can we use the sum of x minus x bar squared, because that's in part B, so really we shouldn't...
Yeah,
worry about
pretend
that.
this doesn't exist.
That's not the
Sometimes
same
English
data
switches
set,
the
because
numbers.
obviously if you add that up, it's not.
Yeah, it's not the same thing. So you're forced to use this one. Or you're forced to use this, right? Maybe I did this one, right? Remember this? Squared, right? X, I think it's squared over n.
Yeah.
Yeah.
Sounds right.
Something like that. And this is squared, right? That's variance, and you got to square root the sucker. Remember that one? Yeah, because that's variance. So you're going to get 36 and change doing stuff here, right?
Yes.
The whole thing, 36 and change, and then square root you get 6. I know I'm going through it fast, but you just have to play with the numbers. I know, it's a math class. Nick?
So we can find the sum of x minus x bar?
Yeah, you already have X bar, right?
Yeah.
And so on. So you put that number right in here, and they said it's 6.085. 58. And then they get a negative, just for fun, you calculated this is negative 2.14. Ooh, it's right on the border. You see that? Yeah, sure, yeah.
So I have to reject the whole.
That's right, here's where the hole is. Hi, Santa.
Reject it.
So this is minus 2.13. You're right at the tip on the critical region. Minus 2.14. You reject the null. Right? Because he's just past the point.
Yeah.
He's at the door. He's not inside. He's outside cold. You ever hear the story about the ant and the grasshopper? Oh, that's a
Yes.
great one from Aesop's Fables. Yeah. So he's the grasshopper that's outside while the ant's working.
I didn't get 6.058.
You didn't get 6.
No.
You didn't get 6.05. Oh, you really?
Did you square root? No, I got 8.8.
You got 8? Really? I'd have to go through it.
Because you takes the number, you subtract 100 from it, and then
85,
you square it.
85 minus
100.
this guy. No, 94.2. That's what, right?
That's
94.2.
X bar, okay.
Okay, X bar. Okay, that's a good thing that she did.
102.
Yeah, don't do 100 because it's going to be a little too much, right? But by default, she would have got it right anyway, right? Most likely she tried to get it right.
Technically,
Yeah, because she's just farther over. They would probably take 2 points off.
No, they wouldn't give you any points.
They wouldn't give you nothing. They're that much of haters. Oh, so okay. Thank you for telling me.
They wouldn't give you a point for the actual answer. They would probably
So
give
this
you a
one's
point for the
right
rejection.
Yeah.
up until
So they would give you nothing for this. Let's say that's 2 points. They give you nothing. You did all that work, and then they start. Oh, she's on track again. I give you half. That's me, because you did all this stuff. I'm like, oh, come on.
They just
You know?
like there's criteria for each.
Yes, I know. They got it. All right. So you reject, and then the statement they said is, boom. You reject the null, right? So there is stat sig evidence to reject the null, et cetera, et cetera. Okay, there is evidence to do whatever. Okay, makes sense? So that's not tough, right? The hardest part was like, I think I was pulling this out of my hair. Okay, not bad. It's the same process, right? Remember, don't use mu for your standard deviation. Use X bar. Okay, Michael, okay? All right.
Are you gonna do this?
Yeah, I can do B, sure. All right, are we okay so far with this? A, yes, Nick?
So when you had on there, isn't the z-score of the management?
Z-score of the management's all here, right? And then this is what you found. So this is
Right.
reject the no.
So the z-score of the management was, let's see, it was.
This guy, this is management, MGT.
So how do we get that?
I have to give it to you on the test. I'll give it to you on the test. I'll call it C of management. People are going to come up, is that the Z? Yes, that's C of management. Go sit down. You know, this is going to happen. Yes?
Isn't it 1.645 because it's a 5%?
No, it's a T. It's a T. It's a different number. You do the same thing. That, if I told you the border is this, that's what the border is. Okay? Not bad? All right, B. Can I erase?
Yes.
Everybody okay?
It's on video.
It's on video. Sophie okay? She's like, yeah. We sure? She didn't say no. Okay. All right, so now we go to the next portion of the program. And it says, gives you B, and it says do 5% and all that other jazz, right? Okay, well, and it does 100, and this is a random sample, I believe it's 80, right? So now N is 80, right? Is that okay? Doesn't that say 80? Yes. Okay? All right, so we have to get some data and so on. Well, the first thing I would do is I go E of X over N. And that's 80 over what? 80. Right?
No, that's not what it
No.
is.
101, sir.
101. Aha.
Okay?
Very close.
1, and then you forget, you did an egregious error. You forgot the 0 there, right? Okay? All right? And then the next one is this guy, right? X minus X bar squared over, and then there's a whole bunch of stuff we have to do, right? 6399. So we take 6399.
Divided by 8.
Yeah, 1 over, if you wanted to do that, divided by 80 minus 1. I'm just showing them to where you're getting it, right? Okay. 63, is it 6399?
I think.
Yeah.
Yes. And
All
then
right.
after the square root.
It's 9, isn't it?
Katie?
What?
I don't know, I heard you muttering. Like,
Oh, I said it's 9.
you're okay?
Yeah, is it 9?
It comes out to 9. 8.944, and they have also an S of 9. They give both for, so let's just say roughly 9. Is that okay?
Mm-hmm.
They give you a range for S. Okay. Now we got all the jazz here, right?
Yep.
I already told you it's a Z, right? So then we just go ho and ha again, right?
What if it fails because we didn't do the 9.4?
Say again.
What if it fails because we rounded it to 9?
If no, it wouldn't fail. If you did 894, you're fine.
Okay.
It says both are acceptable.
All right.
Okay, that's a good question.
What did we get for the standard or the variance?
Variance. Oh, variance is going to be
81.
81,
That doesn't.
and then S is 9. Thank you.
Okay.
Okay, I just was trying to go quick so I can get it.
Standard deviation's not.
Yeah, 81. It's roughly 81. Okay.
Okay.
All right. And so they use 9. So the ho and the ha. So we know it's going to be mu and then a mu here. And they wanted to do what? Obtains the results, denotes whatever, right?
Because not.
And so it's not, so it's a two-tail.
Mm-hmm.
All right.
It's 100, right? We're still using the management one?
You're still doing management, 100, right? How do we know it's 100? Because it says, it's leading off of this, and it says a random sample of club of 100 club members or whatever. It says it even down here. Okay? Or no, that's not, I'm
Not doing the golf.
not doing the golf. Okay, it says
Believing the mean.
80, yeah, random sample 80, right? And then it says the batteries have not changed for 100 hours. Management's 100, sample's 80, okay? I should just cut there, okay? It's hard for me to go, and I'm a guy, okay? That's another thing. All right, so now we got all our stuff, right? So now we do a Z. Here we go. X bar is,
101.
mu is,
100.
S is,
9.
over the square root of
80.
80. And then it's roughly,
The reciprocal of 9.
it's roughly around 0.99, right? Or 1. Okay?
Oh, it's not even close.
Yeah.
It's not even close. Now, you knew it was alpha. Told you that previous, right? Two-tail, it's going to be now the classic 196, right? minus 1.9. It talks about classic statistics. And it's not even close. It's 0.99. And this is failure to reject the null. That was keeper. Failure to reject. It's a keeper. She goes to the Christmas party with you, or goes home with Christmas, or whatever. Him or her. Yes, sir.
So I thought we had to use a t value
No,
instead of the
not this one.
1.9.
Not this one.
But the other one we didn't have to.
Yeah, you did.
So
We didn't normalize it here. See, it gave us just the values, and then when they did something like this regard, now they're trying to normalize it.
okay.
Like, I'll try to lead you into it, and you're in this regard, you're fortunate because they don't do it to you. In like college, they just give you the question, and they're like, which test are you going to do, right? I'm not going to be that mean. I'm going to tell you. I even wrote it, I read it last night, and like, yep, I'm even telling them. I only have one T anyway. If you see a T critical, boom, I got to do T-test, right?
Okay.
All right? And you do the same jazz.
The
Yes, ma'am.
claim would say.
And so it's value to reject, and we say what? Go ahead.
It's not enough statistic to
Yep.
reject the claim that the mean values on the AICE change.
That they are less than 100 hours or something, right? Because remember it was 80.
Yeah.
So the batteries are going to last 100 hours. Yes, sir.
So if we can do the last two problems we just did, that's the test.
There you go. Now he streamlined it. All right.
Yeah.
He streamlined it. Okay. Now I don't know what I didn't cover. How much time? About 5, 7? I don't know.
7.
Okay.
No, not.
If you have, I'll stop there.
I guess.
Whatever we didn't cover, hand it in for the homework. Is that okay? So homework for Monday. Give me a homework assignment. Yeah. Yes, sir.
So the homework is just all the
The
problems that you
stat,
said.
the remaining problems we didn't go over.
Okay.
Just for stat, right?
Just for stat 2.
Thank God.
Because I won't lie to you. Hold on. I won't lie to you that I will pull possibly 1 or 2 off Sammy Cambridge. But you got the answers.
Yeah.
So you're like, oh, that's in the box, in the back.
Memorize the answer.
Well, I won't say that to you. But you get the idea that you can follow the flow, right?
I know.
All right? So you should be okay with these. Anything's fair game on this one. Only difference is I'll tell you T or Z on the test. 5 questions on the test. Extra credit uses the T table. Next week after Tuesday, or sometimes Tuesday or whatever, I'm going to go over iterations. Okay? Or iterations. It means you just repeat the same.